Okay, one of the 5 sections, guys, hey, if you're going to talk, text each other. One of the 5 sections that's going to be on the test is the type of reactions. In this video, I'm just going to review the 5 types of reactions and when you know to use them. If you have a functional group and you want to move it or put something on a different carbon, you have to do an elimination. Okay, so in an elimination, you would take off that chlorine and you would take off one of the hydrogens. If you took off this hydrogen here, you'd put the double bond there. If you take off this hydrogen, the double bond would go there. So you're always removing a functional group plus a hydrogen from one of the carbons that it's beside. So that's when you want to move something from where it is. Addition reactions. Yes, question?
Doesn't it matter what side? Like
this side or this side?
Yeah.
No, it does not matter. So you can put that double bond wherever you need it, as long as it's on one of the, between the carbons where the chlorine was. So it'd have to be there or there. You couldn't move it over 2 spaces.
If we were doing like an actual lab experiment, would we just do an elimination and hope that it, the double bond goes where we want it?
Yes. There's ways of directing it. Okay, addition reaction. Addition reactions are done when you have a double bond in a carbon chain. So your look fors, you must have this before you can do an addition. You cannot add to this. Must have a double bond. What types of things can you add? H plus any group 7 element. So HCl, HBr, HI, HOH, H, NH2. So hydrogen attached to a functional group is your basic look for. The other thing you can add on is any 2 of a group 7 element. So you could add 2 Cls, 2 Brs. When you add it on, you get rid of the double bond. You can put the functional group either here or here, wherever you want it. And the other carbon would get a hydrogen. Substitution. If you have a functional group and you don't like it, you can add a different functional group on by doing a substitution. Here's a key point. This only works for single bonded functional groups. You cannot substitute a double bonded functional group, so you cannot do a substitution here. The redox reactions. Whenever you have a question that has a double bonded functional group in it, this is what you have to use. Double bonded functional group. Ketone, double bonded functional group. Aldehyde, double bonded functional group. We have a carboxylic acid. Folks, you have to memorize these 3 reactions. You have to memorize them. They're the only redox reactions, but in organic chemistry, you need to know them. Alcohol to a ketone. If the alcohol is anywhere in the middle of the chain, you'll make a ketone. If the alcohol is on the end of a chain, you will make an aldehyde. You can turn that aldehyde into a carboxylic acid. Don't mix up oxidation and reduction. What is oxidation? More bonds to O. 1, 2, 3 bonds to O. What is reduction? Fewer bonds to O. 3, 2, 1. These are the higher energy molecules. These are lower energy molecules. Last type of reaction. Whenever you see an ester, you're going to have to do a hydrolysis. So what is a hydrolysis? You are going to cut this into 2 pieces. One piece will be a carboxylic acid, the other piece will be an alcohol. Anytime you see an ester, this has to be your first step. Anytime you see a carboxylic acid and an alcohol, so if you start with these 2 things, your first step is going to be dehydration synthesis. Hydrolysis means to cut using water. Dehydration means to remove water to synthesize. So you're taking 2 things and you're making one big thing. Folks, a quick overview on look fors. We're going to try 4 or 5 pathways right now.